Hello and welcome back to Calculus 1, section 4.3, graphing functions, comma, by hand. So we have technology, we have calculators, and we have Mathematica and other software, right? You use Desmos and Simulab, whatever you use. We can actually do all of this manually. It just takes a long time to do it, but we can. The ultimate way to graph any function is to use what we use in middle school. You pick x values, you compute y's, and you can graph by that method anything. The problem is to actually capture interesting stuff. So imagine that the graph, right, you compute at points and the points go like this. And you say, oh, okay, great. So it's a linear line or something like that, and you draw the line. But then actually what turns out that this graph actually goes like that, and then later bends and then does this. And you completely miss the most important part of the function because you computed points -5 to 5, and all of the interesting stuff happened after, let's say, between 10 and 20. So that's the issue with using the middle school method of computing y values, because what happens if, after 10,000 it starts doing funny stuff? Now, calculus detects everything at once, which is why this method of graphing is by far superior to anything else. Obviously, superior to anything else non-technology, right? So what do? We get what I call a shopping list, right? We have the list. These are the things that you need to find, and then if you put all of these guys together, there's your graph. Yay. Number 1, domain. Number 2, X-Intercept. Number 3, Y-Intercept. Number 4, Va. Number 5, Ha. Number 6, Sa. So Vahasa is there. What's Vahasa? Vertical as and horizontal as and good. Number 7. We need f prime, which leads into first derivative test. Number 8, f double prime, which leads into second derivative test. And then I'll say number 9. Additional points. And number 10, finally graph. Hey. Oh, come on. Sync. I'm just going to do this real quick to make sure. We're sorry, OneNote is clearing up on the first. Fine. So you've seen the shopping list. Some of those things are learned in algebra. Some are learned in PreCalc. Some are learned in calculus. So, really? Oh my God. Really? Really? All right. Guys, there is no lecture here. They're just examples. We are not learning anything new. You take what you learn in algebra, PreCalc, and calculus so far, and you just put them all together to graph something by hand. For instance, graph that function we dealt with before, x, l, and x. by hand. So we know that the domain was 0 to infinity, because domain for x was infinity to infinity. ln x has 0 to infinity, that's more restrictive, therefore it becomes the domain for everything. Number 2, X-intercept, we get that when we set y equal to 0. So we go and say x ln x equal to 0. Now, when we set this equal to 0, we get x equal to 0 or ln x equal to 0. X equal to 0 is already solved. There's nothing to do there. ln x equal to 0, we can e both sides, and we get that x is equal to e to the 0, which is 1. So now we have an x-intercept at 1, 0. Perfect. Number 3, y-intercept, which is when we set x equal to 0. And if we set x equal to 0, we get undefined, because we are supposed to compute 0 times ln of 0. ln of 0 is infinity, negative infinity. So you have 0 times negative infinity. No solution over here. So there is no y-intercept. Now that makes sense, because as we can see in the domain, 0 is x equals 0 is not the part of the domain which is y-axis, and we can't have a y-intercept if the y-axis is a vertical asymptote. All of these things fit together. Already spoiled it, right? Vertical asymptote at x equals 0. 5, 6, so ha, sa, nan. We know that polynomials, x, x squared, x cubed, x to 100, they don't have any asymptotes. And ln has only a vertical asymptote, so you can't just come up with a slant or horizontal. Now we have the first derivative test, number 7. Now that was already done. So first derivative test is already done, and I'm going to steal the results from the previous lecture. Just need to find a where. Hey, there we go. So we have the product rule that needs to be done and do all of this stuff. So everything from here needs to be there. There we go. Oh, I work fast, yes. And we have our first derivative test, and we have our critical point and all of that stuff. So now, except some stuff is missing over here. No walking. The next part is to also find that our Cx value as a critical point over here is 1 over e, so y value is f of 1 over e, which is 1 over e times ln e to the minus 1, which is negative 1 over e. So we know that minimum, it's a minimum, right? Yep, minimum is at 1 over e, negative 1 over e. Second derivative test. is we need a second derivative, which is just 1 over x. Right, the first derivative is 1 plus ln x. The derivative of 1 is 0. The derivative of ln is 1 over x. So there we go. We set this equal to 0 to solve for inflection points, and we come up with the equation 1 equals 0, which is no solution. So entire domain is one partition from 0 to infinity, because we have no vertical asymptotes between 0 and infinity. There is a vertical asymptote at 0. And there are no vertical asymptotes between 0 and infinity, and there are no inflection points either. So the whole thing is one partition. Pick one point. We can pick 1. Calculate the second derivative at 1, which is 1 over 1, which is 1, larger than 0, and the whole thing is concave up. So this is a problem done. We calculated, we found the domain. We calculated the X-intercept. We know that there is no intercept on x equals 0 because there's a vertical asymptote there. But we know the rest. And there is the X-intercept at 1, 0. There are no Y-intercepts. Vertical asymptote is at 0. And then we have the tests, right? First and second derivative test. We can now put this graph together using all this information.
On one side you wrote concave down, but on the graph you wrote concave up.
It is concave up. I'm not sure why is this here. It's definitely concave up. It's larger than 0, right? So the whole thing is concave up. So I have X-intercept at 1. Let's put it here. And I have 1 over e and negative 1 over e. Actually, I'm going to put this one further away. I'm going to put this 6 units away because life. No, 4 units away. That's what 1 is. Now I know I have an X-intercept there. I know I have a vertical asymptote at x equals 0 as a guide. And now I know that at 1 over e and negative 1 over e, which is roughly a quarter, all right, I have a minimum. So quarter, negative quarter, about, is a min. So a quarter, negative quarter is here. Now, and this is the $1 million thing, guys. This thing is trying to have an X-intercept at 0, but we cannot have it because of the vertical asymptote. So it's open circle there. The function is going to make a smiley face at the minimum, right? Minimum is a smiley face and the max is a frown. And it's going to go through this one and check out that way. This is the only way you can put the graph together from the information, to be decreasing up to 1 over e, because we need a decrease up to 1 over e, to have the increase forever after 1 over e. There is the increase forever after 1 over e, to have a minimum at 1 over e, negative 1 over e. So when you put all of these things together, right? Generally, these problems should take, when you start learning and putting all these things together, maybe 20 to 30 minutes per problem, because you are slow at this stuff because you just seen it. The more you do, it speeds up. What I do on exam 3 is I break this problem into sections. So, but I don't know what's going to be on the final. So don't bank on what I do on my test. I'm not writing your final. What I do on the exam, which is exam 3, I give you a problem on min-max, I give you a problem on first derivative test, I give you the problem on second derivative test, and then I give you a problem on graphing where I give you all of the information. You don't have to calculate anything. Your job is to look at the chart of values that I provided and draw the graph. So those are the 4 problems that I give, which actually are all components of this big problem. So again, 4.3 graphing functions. We did not learn anything new. We took all of the concepts from before, put them in a list, and then you have your checklist, and you go check, 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 find everything, and then just put it all together on a graph. Please remind me next Saturday to start with one more of these problems, or if you find one on the homework that is particularly annoying or whatever, I can start with that. And then we have at least 3 or 4 sections next class to catch up, because we've been lagging behind. And I believe, is it the next or the following the Thanksgiving? It's in 3 Saturdays, right? It's not next one. We have 2 classes and then the break, right? No? 1 and then. So keep thinking about that extra Saturday review stuff.
You'll be here on that Saturday, right?
Yep, I'm here every Saturday. I'll see you all in a week.
And the review will be for the final, correct?